Hello everyone, today we'll be covering volumes of revolution. So what is a volume of revolution? All these three objects are volumes of revolution. Why is this so? What a volume of revolution is that it revolves around a certain axis and we are revolving a certain function, let's say this function over here, around this axis in a circular motion. If you see here, we are revolving this function around the axis in a circular motion, and this function over here along this axis in a circular way. Now let's go on to the formula. If we have this purple object over here, and this graph is y equals to fx, can you see that we can cut this into a many slices of circles? And at any x value, the radius over here will be equals to fx, because the y value will actually give us this radius. And hence, the area of each slice, and so the area of each slice will just be pi r square, or pi of fx square. So now, if you want to find the volume of revolution 2 pi around the x-axis, what we're going to do is take the definite integral of pi fx square, and then we'll integrate from the lower x bound a to the upper x bound b. A to b. That's where the function starts and ends. Now what if we want to find the volume of revolution around the y-axis? Let's say this is not revolving around the x-axis anymore, but the y-axis. We now label this function x equals to fy. And in similar fashion, we're going to integrate pi fy square with respect to y. Now if you look here, the two bounds we're going to be using are no longer the x bounds. We're going to be using the y bounds c and d, where the function starts and where the function ends, but in terms of the y-axis. Now, let's try to do this question over here. Find the volume of revolution from y equals to 1 to y equals to 3 when the function y equals to x plus 3 is revolved around the y-axis by 360 degrees. So what we're getting is this over here. Oh, and by the way, these two will be given in your formula booklet. So first, we know that y equals to x plus 3. But if you look here, we need x in terms of y. So now, let's just apply this formula to find the volume of revolution. My volume will just be the integral, and we have our two bounds here, y equals to 1 and y equals to 3, so let's just use it. And then we have pi of fy square, so we have y minus 3 square, and then dy. And now if I expand, I'll get something like this. Now let's just do our integration. This becomes y cubed over 3 minus 3y square plus 9y. And we'll put our bounds as 1 and 3. Now if I actually calculate this out, I should get 8 pi over 3. Now the last thing we're going to do is to find the volume of revolution between two curves. So if we're trying to find this yellow volume over here, this kind of works similarly to the area under the curve. We want to take the volume of the upper function minus the volume with the lower function. So the volume of revolution using the upper function will just be pi of the upper function square. And then we want to minus pi times the lower function squared. That's your volume of revolution for the lower function. And similarly, we'll take our two bounds over here where the volume starts and ends. I want you to remember, this is a common mistake. This is not the same as taking pi times the upper function minus the lower function squared. This is wrong. If the orange curve looks something like this instead, what we have to do is split the integral into two parts again. Remember, this works very similar to area under curve. So let's say we have something like this. Now if I want to find the volume between these two curves, the first part is this yellow part over here. I'm going to take the volume of revolution of the upper function minus the volume of revolution of the lower function. In this case, the upper function is the purple function. So I'll take the integral from a to b of pi of the purple function squared minus pi of the red function squared. But for this part over here, if I want to find this remaining volume between the two curves, then I'll have to take the definite integral from b to c, again that's where the bounds are, and then since the red function is now the upper function, we're going to take pi of the red function square and then minus pi of the purple function, which is the lower function, squared. Alright, here's the summary sheet for volumes of revolution. Thank you so much for watching.